This presentation is about the first two stages of wound healing, the homeostatic and the inflammatory stage. Homeostasis means blood stopping, and it's to do with the reduction of bleeding. This slide shows an intact blood vessel with all the circulating cells, red blood cells, platelets and leukocytes. When the endothelium is intact, the platelets circulate in the blood and do not adhere to the surface. Also, when the endothelium is intact, anticoagulants, procoagulants and thrombolytic substances are in balance with each other. Upon vessel injury, the subendothelium is exposed. Platelets interact with von Willebrand factor, located in the subendothelium. This leads to the adhesion of platelets around the area of injury. After adhesion, the platelets are activated. This activation causes the platelets to change shape. When the platelets attach to the endothelium, they release more von Willebrand's factor, which helps in the adhesion and activation of more platelets. Once activated, platelets release a number of substances. These substances perform a number of different functions. They can promote the activation of more platelets, for example thromboxane A2 and adenine diphosphate. They can work in the clotting cascade, for example calcium ions and clotting factors, or they can help in the regeneration process, e.g. growth factors and fibroblasts. As well as helping with platelet aggregation, thromboxane A2 is also a vasoconstrictor. Vasoconstriction reduces the amount of blood moving through the area and thus reduces the amount of blood loss. Exposure of tissue factor results in the extrinsic pathway of the coagulation cascade. The extrinsic pathway is called the extrinsic pathway because you need to add something extrinsic to initiate the pathway in the laboratory. In the body, the extrinsic pathway is initiated by a tissue factor, which is extrinsic to the blood and only comes into contact with the blood due to disruption of the endothelium. On the other hand, nothing is added to the intrinsic pathway in the laboratory for its activation. All components needed for the activation are present within the blood. The common pathway is the merger of the final stages of both the intrinsic and the extrinsic coagulation pathways. This slide shows a common pathway. Activated factor 10 helps in the conversion of prothrombin to thrombin. Thrombin has many functions, both in terms of the coagulation cascade and the inflammatory process. It interacts with the complement system. The complement system is involved in the inflammatory process as it helps to recruit inflammatory cells. The complement system is also part of the body's innate immune system. In terms of coagulation, thrombin helps promote platelet aggregation and activation. Thrombin cleaves fibrinogen, which leads to the formation of fibrin. Fibrin, along with platelets, creates a homeostatic plug to reduce blood loss. Factor 13, which is part of the coagulation cascade, helps to stabilise the fibrin clot through induction of fibrin cross-linking. As well as activating elements of the coagulation cascade, thrombin also acts to decrease the production of clotting factors. When levels reach a certain threshold, the presence of thrombin will inhibit the activation of factors 5 and 8. This mechanism means that the clotting reaction is not too excessive. Vasodilation caused by release of histamine from platelets is a major factor in the inflammatory response. There are 4 signs of inflammation. They end in the suffix OR. Rubor, or redness, is caused by the increase in blood flow to the wounded area as a result of the vasodilation response. Calor, or heat, is caused by the increase in blood flow, which brings heat from the core to the periphery. This increase in blood flow helps the wound to heal by bringing more red blood cells to provide oxygen and nutrients to provide for the metabolic requirements of the healing tissue. Increased blood flow also means there are more leukocytes to deal with any pathogens that have entered the body via the wound. Phagocytic leukocytes such as monocytes, neutrophils, eosinophils, phagocytose and destroy pathogens. Selectin expression near the site of a wound is controlled by histamine and thrombin. Selectin expression aids in the movement of leukocytes closer to the site of the wound. When the leukocyte is near the site of the wound, it migrates across the endothelium to the tissue layer so it can tackle any invading pathogens. The process of leukocyte migration across the endothelium is called diapedesis. The diapedesis of leukocytes is partly responsible for the tumour or swelling seen in the inflammatory response. The 4th OR of inflammation is dolor, or pain, and is caused by the release of chemicals involved in the inflammatory response. These chemicals irritate nerve endings. As well as the 4 ORs of inflammation, there is a 5th sign that can occur, and this is loss of function. Loss of function can be due to pain, oedema, or replacement of functional tissue with scar tissue. That concludes the first 2 stages of wound healing. After these stages comes the proliferative phase and the remodelling phase.